So in question 8, we're given a graph of a curve here, y equals g of x, and then we're given the equation for g of x here. For 1 mark, find the y coordinate of the point at A. The easiest way of doing this, A occurs when x equals 0. So we're literally just finding g of 0 and plugging that in. Giving mod 4 e to the 0 minus 25. Now e to the power 0 is 1. So we get mod of 4 minus 25, which is mod of minus 21. So the answer is 21 for the y coordinate of A. So well, that's it for this question in terms of that 1 mark. I think it's worth just reviewing what is going on with this graph and this function, just making sure that we understand how that graph is working. So we'd start by looking at the graph of y equals e to the x and recalling the general shape of the graph and that it cuts the y-axis, x is 0, y is 1. For now, look at the graph y equals e to the 2x. And e to the 2x still goes through at that point 0, 1, when x is 0, y is still 1. It just increases much more rapidly to the right and tends to 0 much more rapidly to the left. So now if we just have a look at 4e to the 2x, this time all of my previous y coordinates have now been multiplied by 4, so it cuts the y-axis at the point 0, 4. And retains that shape. If we now subtract 25 from that, and it shifts the graph downwards, and now we're taking the modulus of that. So the part that is already positive and above the x-axis will remain there. So for y is the modulus of this function. That part just stays above there, and this lower part gets reflected up. And it will cross there at plus 21 instead of minus 21 there. So I can see that that makes sense. And I could also go on to work out my coordinate of B. Not that it's asked in this question. But if we were just looking at my purple graph here of 4e to 2x minus 25, I just want my y coordinate to be 0 for it across the axis, and then I solve that. Could leave it as a log, ln of 5/2, or evaluate.